This is a universal bevel protractor, often referred to as a vernier protractor, and its purpose is to measure angles. There are several different parts to this universal bevel protractor. What we have here is the base that the measurement is taken from. It also acts as an area for an acute angle attachment tool to be added to, which I'll show you in another photo. Down here we have the blade, which is actually inserted through a groove and tightened with this nut here. And it actually will articulate around the protractor and allow you to measure the angle against the base. We have two scales on this protractor. We have a main scale, and there's actually 4 quadrants of it of 90 degrees. So if you have a look here, you can see 90 degrees, and then it goes right and it goes left of that 90 degrees. If you have a look just underneath this magnifying glass here, which is used to help magnify the measurement because it can be a little tough to read, we actually have the vernier scale. This scale is divided into 2 quadrants of 12 divisions each. And what it's trying to do is it's trying to magnify the degree. So in other words, it'll break a degree down into 12 parts, or 5 minutes of a degree. So the accuracy of this tool is 5 minutes of 1 degree. We have a lock nut here, so if we unlock this nut, we can then swivel the blade, swiveling the main scale to whatever angle we require, and then we can tighten it. This is a fine adjusting wheel, so once the lock nut is unlocked, we can use this to turn to dial the angle in to whatever degree we require. This photo shows the universal bevel protractor checking a part. The part would be set in against the base, and with the lock nut loosened, this blade would then be brought down into contact with the far side of the part, and then the reading is taken off of the scale here. This is an example of the angle being checked on another part. This picture shows the acute angle attachment which has been added to the base of the universal bevel protractor. This is used to measure angles smaller than 90 degrees. Let's have a look at how the universal bevel protractor is read. So if you have a look on the main scale here, you can see each division is a full degree. This particular one happens to be going in the counterclockwise direction. If you have a look down on the vernier scale, you will notice there are 2 sides to it. There is a scale from 0 to 60 going in the counterclockwise direction, and we also have a scale from 0 to 60 that goes in the clockwise direction. This will become very important. So we want to have a look at the 0 on the vernier scale and line it up with the main scale. And you can see we're just slightly past 40, 41, 42, 43, 44, 45 degrees, not quite 46 degrees. So we can say that the main scale has an accuracy of 45 degrees. Now, after we find out the full degrees, we're going to put our eyes down onto the vernier scale, and we're going to start to move along it. Again, because the main scale moved in the counterclockwise direction, we're going to do the same thing on the vernier scale. This is really important. So again, each graduation on the vernier scale is 5 minutes of a degree, so we're going to have a look down until we see a line that lines up with the main scale. So 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, 30, 35, 40, and it looks to me like the 45-minute symbol lines up. So we can say that the accuracy of this particular reading is 45 degrees, 45 minutes. Here's an example of another reading. Please notice how the scale this time is going in the clockwise direction. So if we have a look at the vernier scale, you will notice it's past the 10 degrees. As a matter of fact, it's 11, 12, 13, 14, but not quite to the 15 degree. So we can say that the main scale has a reading of 14 degrees. Now we're going to take our eyes down onto the vernier scale, and what direction are we going to read in? That's right, because we read the main scale in the clockwise direction, we're now going to read the vernier scale in the clockwise direction. So if we have a look down here, and we're going to look for a line that lines up with the main scale. So 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes, and it looks like the 30 minutes is where it lines up. So we could say this reading is 14 degrees and 30 minutes, which is also 14.5 degrees. Let's try one last reading. Again, you'll notice that the scale is moving in the clockwise direction. The 0 on the vernier scale is just past 25, 26 degrees, not quite 27 degrees. So we can say that the main scale has a reading of 26 degrees. We'll take our eyes down and we'll look on the vernier scale, and it looks like the 50 degree lines up. So we can say this reading is 26 degrees, 50 minutes. What if we made an error and we had a look on the other side? So if we were to go 26 degrees and then take our eyes down to this side, you'll notice that approximately the 10 minutes lines up. So if we were to say 26 degrees and 10 minutes, you can see that would be quite an error from the true reading. So again, if it's getting larger in the clockwise direction, we want to make sure and continue along in the clockwise direction on the vernier scale. Just to recap, this universal bevel protractor has 4 quadrants, and each quadrant is 90 degrees, and it runs in 2 directions, either clockwise or counterclockwise. Also too, if we come down to the vernier scale, you will notice it is broke up into 12 graduations, each graduation being 5 minutes of a degree. So we can say that the universal bevel protractor has an accuracy of 5 minutes of a degree.